Hello everyone, welcome back to Easy Engineering. If you're new here, I'm glad you found the channel. This video is part of a YouTube course that covers how to use SOLIDWORKs for complete beginners. In this course, we reference this textbook by SDC Publications to cover SOLIDWORKs fundamentals, practical engineering workflows, and exercises to help you confidently prepare for and pass the SOLIDWORKs CSWA certification exam. If you're interested, I have posted links in the description to the textbook and downloadable files that come with it. If you'd like to keep up with the rest of the course and future engineering tutorials, consider subscribing, and if this lesson was helpful, leave a like to help support the series. Thank you. In this video, we're going to build this part from start to finish. This is the final component we'll be creating, and by the end of this lesson, you'll be comfortable going from technical schematic to a fully defined 3D part in SOLIDWORKs. For this exercise, we'll be following a textbook example that focuses on part creation and modification. The goal here isn't just to model the shape, but to practice a clean, logical workflow that mirrors how parts are actually built in engineering environments. Okay, let's go ahead and get started by opening a new part file. We're going to go to File, New, and then we're going to go Part, and then press OK. Now that we have opened up our new part file, let's go ahead and make our reference planes visible. And then proceed into the isometric view. Now that we are in the isometric view, let's go ahead and take a quick look at the exercise problem. As we can see from the schematic, the exercise problem gives us two variables, variable A and variable B. A is 100 and B is 40. Noting the unit system is in millimeters grams second, this tells us that variable A is going to be 100 millimeters and variable B is going to be 40 millimeters. Below the schematic, we can see the reference origin used when creating this part. Noting where the origin is, this will allow us to create the model correctly. Before we begin modeling the part, we need to make sure that we establish the correct unit system inside of SOLIDWORKs. As you can see down here, the default is going to be an IPS. We're going to go ahead and move that to millimeter gram second. Now we can go ahead and assign our variables, going to the equations table in our feature manager tree, right click, and then press manage equations. Now that we have opened up our equations table, we're going to go ahead and assign the variables A and B. Now that we've established our variables, we can go ahead and press the OK button, and then proceed forward. Analyzing our schematic once more, we can see that the provided origin for this part is going to be at the bottom left corner of the component. Taking this into account, we will begin modeling our part revolved around this origin. Let's go ahead and jump into the front plane and create a sketch. Within the sketch, we're going to be using the corner rectangle option, and then we're going to start our rectangular shape from the origin and then expand outward. After we've created the rectangle, we're going to dimension the lengths using Smart Dimension. You can either click this button right here to access the Smart Dimension tool, or use the quick access wheel through mouse gestures. Using the Smart Dimension tool, we're going to define the top edge of the rectangle as variable length A. To do this, you have to use the quotation marks, type in the variable name, and then close quotation marks. After doing this, you can go ahead and press enter, and it will assign the variable length to this line. Then you press the check mark. After doing this, we can go ahead and establish the height of the rectangle by defining it as variable length B. Now we have established our rectangle, we can go ahead and press the checkmark button right here to close the sketch. Now the sketch is closed and it's still highlighted in the feature manager tree. You can go ahead and either use the basic modeling tools tab to go into extrude boss base, or you can go to features and then extrude boss base from here. Referring to our schematic once more, we can see that the origin is going to be in the bottom left corner of the component. Following the schematic's origin reference, we're going to need to extrude this rectangle from the defined origin. In order to do this, we need to make sure that our direction 1 option is set to bind and not any other of the options. and then we need to switch the direction. That way, as you can see here, this will be our origin, and the extrusion is coming out from this point, or from the plane where this point lies. Following the schematic, the dimension for this length, or the dimension for the extrusion, is going to be 60 millimeters. After defining the extrusion, we can go ahead and press the green check mark in the feature manager tree, or press the green check mark on the right side of the window. Now that we have created our raw stock and our raw material, I'm going to go ahead and disable the viewing of our reference planes. To do this, I'm going to press the S button on my keyboard, and from there I'm going to access the Quick Shortcuts toolbar. From here, I have the option to disable the view planes. If this option does not show up for you, what you can do is you can disable the view planes by coming up to the heads-up toolbar, where the eyeball is, pressing the drop-down menu, and then turning off view planes from here. Referencing our schematic once more, we can see that we need to perform 3 extrude cuts. On the left side of the prism, the right side of the prism, and from the top side of the prism. There are various ways to do this, however I'm going to present one of the many options that you can choose. Selecting the top face of the prism, we're going to go ahead and press Sketch. Within the sketch, we can see how we are oriented on the top side of the prism, and we need to perform a downward extrude cut 10 millimeters from the bottom of the part, towards the bottom right side of the prism. To do this, we're going to select the corner rectangle feature again in order to create the sketch for this extrude cut. With the corner rectangle tool selected, we're going to start the sketch from the bottom right corner and then come outward this way. Using the Smart Dimension tool, we're going to define the length of this sketch based off the schematic, choosing the left edge of the rectangle and then choosing the left edge of the prism. We can go ahead and define this as 20 millimeters. Not 200, 20. And then to establish the height, we're going to select the top edge of the rectangle and the top edge of our prism. And then we're going to define this length as 20 millimeters. With the rectangular sketch for the first cut extrude complete, we can go ahead and press the check mark at the top right of the plane. With the sketch closed, but still highlighted in our feature manager tree, we can go into the extrude cut feature. In doing so, I'm going to go ahead and return to the isometric view of our model. As we can see here, SOLIDWORKS has referenced the previous extrusion that we made and bringing it over into this new extrusion. The previous extrusion was defined as 60 millimeters. However, for this extrusion, we just need it to be 10 millimeters from the bottom of the prism. You can either do this by subtracting 10 millimeters from length B, which was 40, and then you could establish this height to be 30 millimeters. Another way to do this, to keep it more consistent with the schematic, is by pressing the drop-down menu and going offset from surface. In doing so, we're going to rotate the model, select the bottom face of the prism, and then establish that the length of our extruded cut needs to be offset 10 millimeters from the bottom of the prism. Now that we have defined our first extruded cut, we can go ahead and press the check mark to exit the feature. Moving on to the second extrude cut, we're going to be selecting the interface of our first extruded cut, and then we're going to draw a sketch. With the sketch, we're going to use the corner rectangle tool again. We'll begin this rectangle at the top left corner of our prism, and then drag outward. Using the Smart Dimension tool again, we're going to define the lengths of this square by selecting the bottom edge and defining it as 20 millimeters. Now clicking the right edge of the rectangle, we're going to define it as 20 millimeters again. This creates a square for our sketch, and with the sketch complete, we can go ahead and press the check mark over here. With the sketch still highlighted in the feature manager tree, we can go ahead and select the extrude cut feature again. Returning back to the isometric view so we can get a better view of how this cut will look on our part. As we can see from the schematic, At this part of the prism, this cut is going through the entire width. To do this, we can go ahead and select the drop-down menu for direction 1 and press through all. This will now cut out a portion of the prism from our sketch plane through the rest of the material. Pressing the check mark here, or at the top right corner of the window, we can now exit this feature. In order to perform the last extrude cut, we can perform the same process as we did previously and by selecting the inside face right here to create our sketch. Or another method that you can do is by selecting the back face of the prism, then drawing our sketch from here. This time we'll be selecting the top left corner of the prism and dragging outward this way. Using the Smart Dimension tool, we're going to define the top edge of this rectangle to be 30 millimeters. And we'll define the height of the rectangle using this edge to be 10 millimeters. Now that the sketch is complete, we can go ahead and press the check mark at the top right of the window to exit the sketch. With the sketch still highlighted, we can go back to the Extrude Cut feature, returning to the isometric view. As we can see here, SOLIDWORKS has transferred over the settings from our previous extruded cut and brought it into the current Extrude Cut feature. If this model had contained any portion of material that was coming out in the vertical up direction from this face, it would then be cut by this extrude feature. Since we are doing a through all cut from the back of the prism and then coming outward, this is the result of the extrude cut. If we had performed the sketch on the front face of the prism here, the extrude cut would then be going in the opposite direction, outward this way, which would be fine. However, since we don't know if this extrude cut comes through the entire material, we shall be changing the selection from through all to up to surface. With this direction selected, we will now select the interface of the prism here. This will now establish a perfect cut from the back face to the interface of the prism. We can now press the green check mark to close the feature. This now completes the modeling process for this exercise. Before viewing the results, we need to make sure that we assign the correct material. In order to assign the correct material to our part, we need to move to the Feature Manager tree and right-click on the option where it says Material. In doing so, we will then edit the material of the part. And in the search bar, we'll be typing brass. Now we can go and select the corresponding material and verify that this is the correct material using the mass density. As we can see, the numbers are a little bit off, but this is just because the units are a bit different. From the schematic, we can see that the density is defined by grams per cubic millimeters. However, in SOLIDWORKS, the mass density is defined by kilograms per cubic meters. It is important to note that these two mass densities are equivalent to one another. If you were to convert 8,500 cubic meters to grams per cubic millimeter, the values would be the same. Pressing apply, we can now assign this material to our part. Then we can press close. With the material assigned, this now completes this exercise. Let's move on to verifying our results. Reviewing the answers for this exercise, we can now verify our SOLIDWORKS results by going to the Tools menu at the top of SOLIDWORKS, going all the way down to Evaluate, and then selecting Mass Properties. I have a keyboard shortcut assigned to Shift-Z to access Mass Properties. As we can see here, the volume from the answers in the image to the volume that SOLIDWORKS provides match. We can also notice that the center of mass values provided by SOLIDWORKS match the values in the image, along with the mass matching as well. After verifying our SOLIDWORKS results to the textbook answers, this exercise is now complete. And that wraps up this lesson in the Easy Engineering SOLIDWORKS 101 Beginner course. In this video, we focus on building the part with a clean, logical workflow, starting from the drawing, modeling step by step, and verifying the final result. If you're following along with this course, I recommend continuing in order so each lesson builds on the last. And if you're curious to explore more, feel free to check out the rest of the channel where I break down other engineering courses, tutorials, and work examples using the same clear, fundamentals first approach. Thanks for watching. I'll see you in the next lesson.